Hey everyone, and welcome back. Today, we are jumping straight into a super fast review of the Unit 2 exercises on data science methodology. We're skipping the theory. This is all about pure application. So let's get right to it.
So, you think you've got this stuff down? Here's your chance to prove it. I'm going to fire a bunch of questions your way straight from the exercises. Try to get the answer in your head before I show you the solution. You ready for this? Let's go!
First up, we've got the objective questions. This is going to be a rapid-fire round with multiple choice, matching, and ordering, so you got to be quick.
Okay, question 1. What's often called the hardest stage in the whole methodology? That would be business understanding. And why is that? Well, because if you don't ask the right question from the get-go, even the best model in the world won't help. Next, what perspective do business sponsors use to define objectives? No surprise here, it's a business perspective. They're trying to solve a business problem after all.
All right, now for a little matching game. Let's connect these ideas. Descriptive analytics tells you what's happening, the current status. Diagnostic goes a step further to tell you why it's happening, using statistical analysis. Predictive, of course, looks into the future to guess what's likely to happen. And finally, prescriptive tells you what you should do about it, how to solve it. And there you have it, a perfect match.
Question 4 is all about the logical order of operations. You have to start with step 1, identifying what data you even need, the content, formats, and sources. Then, for step 2, you go out and get it and figure out if you need more. In step 3, you start to actually understand what you have with some basic stats and visuals. And you wrap up with step 4, finding and plugging any holes in your data. That's the flow.
Moving on. For question 5, data modeling really boils down to two main types of models, predictive or descriptive. Now for question 6 about train test splits. Statement 1 is absolutely true. There's no magic split percentage that works for every single project. And that makes statement 2 false. You know, an 80-20 split is super common, but we can't say for sure it's the most common one used everywhere.
Okay, 3 more quick ones. Question 7. Where do you find the train test split function? That's in sklearn.model-selection. Question 8. What's the big lie about cross-validation? That it's fast. Nope. It's actually pretty heavy on your computer because you're training a bunch of models, not just one. But the payoff is a much more trustworthy evaluation. And for question 9, figuring out your data content and sources happens way at the beginning in the data requirement stage.
For question 10, we're looking for the odd one out. UNICEF, WHO, and Google all provide data. Edge is just a browser. It's how you get to the data. Okay, question 11. A chunk of historical data where you already know the answers, that's your training set. It's the textbook your model studies from. And how do you know if it actually learned anything? You give it a final exam with the test set, which is data it's never seen before.
And the last of the objective questions. Question 13 is just simple math. If your test size is 20%, or 0.2, then the training size is whatever's left, which is 0.8. Question 14. What's the K in K-fold cross-validation? It's just the number of folds, or pieces, you split your data into. And finally, for question 15, the two big things to know about mean squared error are, it's a go-to for regression problems, and because it squares the errors, it really punishes your model for being way off.
Whew, great job on that section. Now, let's take a breath and slow down just a little bit. For the short answers, these need to be quick but clear.
Okay, first, a two-parter. How many steps are in the data science methodology? There are 10, starting with business understanding and going all the way to getting feedback. The second part asks, what's feature engineering? This is where the magic happens. It's the art of using what you know about the subject to create brand new features from your existing data. Good feature engineering can totally transform a mediocre model into a great one.
Next up, data sources. It's pretty simple. Primary sources are the data you go out and collect yourself for your specific project. Think running a survey or setting up sensors. Secondary sources, on the other hand, are data that somebody else already collected that you can just use, like grabbing a dataset from a website. The big difference is just who did the original work. Let's talk about two really critical stages. Data understanding is basically a reality check. You've got the data, but is it the right data? Is it going to help you solve the problem? Is it complete? Then you move into data preparation, which, let's be honest, is usually the most time-consuming part of any project. This is all the cleaning, merging, and wrestling your raw data into a clean format that a model can actually understand. This table does a fantastic job of showing the trade-offs between a simple train test split and cross-validation. The main takeaway? A train test split is fast and works well when you have a ton of data.
But cross-validation, while slower, gives you a much more reliable score, especially with smaller data sets, because it makes sure every single data point gets a turn to be in the test set.
So, why do we go through all this trouble with model validation? Well, think about it. A model that gets a perfect score on the data it trained on is totally useless if it can't handle new data it's never seen before. Validation is our way of making sure the model has actually learned the general patterns and hasn't just memorized the training data. It's our defense against overfitting and building a model that's unreliable in the real world.
All right, let's get into the long answer section. For these, we need to break things down and explain the process step by step.
This diagram is the perfect way to understand k-fold cross-validation. Here, k is 5. See how the data is split into 5 folds? In the first experiment, we use fold 1 for validation and the other 4 for training. Then, in the second experiment, fold 2 gets to be the validation set. This rotation happens 5 times, which means every piece of your data is used for both training and testing. It's a really robust way to check your model's performance.
So what's the journey from just having a problem to having data that's ready for a model? It's this 4-stage pipeline. You start by defining your data requirements, then you move to data collection. Once you have it, you enter data understanding to see if it's any good, and finally, you have data preparation to get it all cleaned up. These 4 steps are the foundation of basically every data project.
All right, we're in the home stretch. Last section. It's time to apply everything we know to some real-world scenarios and calculations.
We've got 2 case studies here. In the first one, which is a regression problem, the mean squared error comes out to 145, and the root mean squared error is 12.04. In the second case, a classification problem, we crunch the numbers from the confusion matrix and we get an accuracy of 85%, precision of 78.9%, recall of 83.3%, and an F1 score of 81.1%.
Let's map these real-world scenarios back to our methodology. An investment firm trying to figure out what its clients want? That's a perfect example of the very first, crucial stage, business understanding. What about an online platform checking to see if its recommendation engine is actually any good? That fits perfectly into the evaluation stage where you're testing how well your model performs in the wild.
And that is every single question. We really blew through that. Let's do one last super quick recap just to make sure all these key ideas stick.
Think of this as your final little cheat sheet. We've hit on the big methodology stages, the key modeling ideas like feature engineering, the essential validation techniques you'll be using, and of course, the critical metrics for both regression and classification. It's all about knowing what tool to use and when to use it.
And there you have it, all exercises done. You just powered through a rapid-fire drill of the entire Unit 2 exercise set. Really fantastic work. Keep this energy up, and I'll see you in the next one.